Welcome, algebra students, to your first instructional video of the year, the 4-step plan for solving problems. So we have our little problem solver guy here. Alright, so what are those 4 steps? Step number 1 is understand. So we read the problem and we do our best to figure out exactly what they're trying to get us to find. Number 2, plan. We figure out exactly what the plan is going to be. If we're writing an equation, we figure out what kind of equation. If we're making a table, etc. Number 3, solve. We actually go ahead and carry out that plan. Figure out what it is that we were going to do, actually do it, find a solution. And finally, number 4, check. You go back, you read it again, you make sure you actually found what they wanted you to find. So let's take a look at a couple of ideas of ways we can lay out our 4-step plan. Then we'll take a look at some ideas for problem solving and go ahead and solve 2 problems. Haha, joke's on me. I had to come back and record at the end of this. It ended up being 3 problems, not 2. Sorry, 3 problems. Okay, so this is a template that we have in Hampton City Schools for these problems. And before you start frantically copying everything, just stop for a second and think about what makes sense. It doesn't really make sense to copy word for word what you see on the page. You don't need it word for word. You need the general gist of it. You need your own spin on it so that you can understand exactly what it is that you learned from what we were doing. The part that you write down is kind of your understand portion. So let's figure out what we're going to write down this time. You work in a supermarket. Your boss asks you to arrange oranges in a pyramid for a display. The pyramid's base should be a square with 25 oranges. How many layers of oranges will be in your pyramid? Well, it's important to note that we are making a pyramid, that the pyramid's base, we want 25 oranges and then it should be a square, and that they want the number of layers, not the whole number of oranges, the number of layers. So I'd give this problem a name, like supermarket problem. I have a better stylus than this. I promise to go find it in a few minutes. Okay, supermarket problem. And I jot down a few things, that it's going to be a pyramid. Now I can write it, or I can get fancy, and I can just draw a quick pyramid. Don't be jealous, I've been doing this a long time. Although it is a little difficult with a stylus. That we want the base to be 25 oranges. And we want to know how many layers. Okay, so I will pause for a moment and go get the other stylus, see if we can do a better job than that. Okay, I stopped for a snack too, but I'm back now. Okay, so in our plan, we have to think about how it is that we're going to figure this out. So the first thing that pops into my mind is that I need to visualize it. So I'm going to visualize the layers of that pyramid by drawing a picture. Okay, on to the solve and check portion of the plan. Of course, the problem won't move with me, and I can't for the life of me figure out how to get it to move. Yeah, I can't. So we're just going to leave it where it is, and you're going to bear with me. Alright, so let's solve, and let's go ahead and draw our picture. So, oranges, 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 5 oranges, and then 1, 2, 3, and then 4 oranges sitting on top of those 5 oranges, and then 3. I don't know why they're getting smaller. Oop, hey, that's apparently a transparent orange. And there we have 1 more. So how many layers do we have? We have 1, 2, 3, 4, and 5 layers. 5 layers. Now, for me, what would be the most challenging thing about this problem when it gets to that check portion, because I tend to forget to do the whole checking part, because I'm too, sometimes I rush, sometimes I'm a little too eager to do the problem. In fact, when I started this problem and I actually recorded an entire segment, I found the total number of oranges in the pyramid the first time. And when I got to the check part, I talked about reading the problem again. And when you read the problem again, it's number of layers. I know, it's ironic, the math teacher screwing up the math problem. Okay, time to move on. So this is a blast from last year for my folks who were with me last year for pre-algebra, for Course 2 Honors. So we're going to go ahead and take a look at the ostrich llama count problem. Remember, do not copy. It is ridiculous to copy word for word. You don't need it. Instead, take some notes. While I read the problem, I will highlight the important information. Raul and Esteban just started working at their uncle's farm on the weekends. Their first task was to count the ostriches and llamas. When they reported to their uncle, Raul said, "I counted 47 heads." Esteban added, "I counted 122 legs." "How many are ostriches? How many are llamas?" asked their uncle. "It's getting dark, and I promised your mother I'd get you home for dinner. There's no time to count again. You'll have to figure out how many ostriches and how many llamas there are from that information when you get home. Can you give me a call after dinner and let me know your answer?" Well, how did Raul and Esteban figure out how many ostriches and how many llamas there were? Whew, okay, so 47 heads, 122 legs. Well, the best way to do this problem, the optimum way, the most efficient way, would be to write something we call a system of equations, which we will learn how to write later this school year. Right now, the best strategy in our arsenal is probably going to be making a table, a little bit of guess and check action. So I'm going to go ahead and do this problem out for you in some guess and check. Give me just a moment, let me set up a table. Okay, so in my table here, I'm going to start off by, let's be generous. Let's say there are 30 ostriches, which means that's 60 ostrich legs, and that means there are how many llamas? Well, if there's 47 heads, then how many? Yeah, I heard one person say it, 17. Okay, so how many llama legs would that be? What we need is 4 17s. Well, 2 17s is 34, and 2 34s would be 68. And that's 128 legs. Hot dog, I got close on the first try. So let's figure out what we need to do here. Well, we need fewer legs than that, which means we need to up one of these two numbers. We either need to up the ostriches or the llamas to give us fewer legs than this total. So which one would we have to do? And of course, I'm just kidding. I can't actually hear you, but I'm sure someone out there said increase the number of ostriches, decrease the number of llamas. So let's do that. Let's increase the number of ostriches by 2. Let's make it 32. 32. That means that's 64 legs. How many llamas would you then have to have? Well, you'd have to decrease the number of llamas by 2 to 15. And that means you'd have how many llama legs? 4 times 15? 60, like the 4 portions of the face of a clock. 4 quarters of an hour, 15 minutes each one, 60 minutes. So when we add that up, that's 124. Okay, one more ostrich, 66 legs. One less llama, 56 legs. And hot dog, that's 122. So now we know. Uncle, well, they didn't give the uncle a name, but Raul and Esteban's uncle. Okay, uncle, there are 33 ostriches, and there are 14 llamas. Very good. Now, I didn't identify all 4 parts of that plan, but you noticed how we went about using them. The understand portion was highlighting the parts of the problem. You were writing it down. The plan part was when I said, we're going to make a table. The making a table is the solving. This right here is your checking, and you're summarizing the problem at the end. Okay, you have to identify which one's which. You have to say 33 ostriches and 14 llamas. Otherwise, the person who you're giving your answer to may think that you were going to have it the other way around. Okay, one more problem. Mrs. Rowe is 3 times as old as her daughter Pam, who is twice as old as her brother Sam. If their total age is 54 years, how old is Pam? Now this is a problem where you may actually go ahead and write down at least the vast majority of what you see here. But I'll go ahead and write down what it is I would write down if I was doing this problem in my notes. Okay, Mrs. Rowe is 3 times older than Pam. Pam is twice as old as Sam. Altogether, 54 years. Now this is the kind of problem that really bothers people. It sounds very difficult, but there's one method that we are going to use in class called Singapore math, and that's how I'm going to do this one. And it's a visual model, and I wonder if any of you actually used Singapore math in elementary school. If you did, mention it to me in class. So let me show you how this works. This little rectangle is 1 unit. So what we're going to do is we're going to have that be Sam's age because he is the youngest. And so his age is the smallest. So we're going to have him be Sam, be that little unit there. Okay, Pam is 2 times older than Sam. Okay, so there you go. That's Pam. Pam is twice as old as Sam, so this is Pam. Okay, all right, and then what's going on with Mrs. Rowe? And there's Mrs. Rowe. Let's write that across it. Mrs. Rowe, all the way down. Okay, so there's her age. She's 3 times older than Pam. So at this point now we're going to look at this and say, well, how many units is that total? We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So we have a total of 9 units, and 9 units is equal to a total of 54 years. 9 units equals 54 years. So that means 1 unit would equal 6 years. If 1 unit is equal to 6 years, and Pam, her age is made up of 2 of those units, well, that's 2 of those 6. Pam is 12 years old. And we have figured it out. Okay, well, that concludes our video on the problem-solving process. One last slide for you before we conclude. You can pat yourself on the back. You just finished your first flipped algebra lesson. I'll see you in class.